Thank you. All right, this is weird. I don't usually have two things in my hand. So hey, I'm Andy Trimble. I'm a principal engineer at Catalyst / architect. Again, I do a whole bunch of stuff. So I'm going to talk to you today about our selection process. This talk is a little bit different. We're a Series B startup, so we're still pretty early in our journey, which kind of gives us a lot of leeway when selecting a technology stack. So we did some kind of interesting things to actually make this selection. I'm going to kind of walk us through that. So I'm going to start off, this is going to be a little product-y, if you will, just to provide you the context. I think it's really important to understand the context of Catalyst to understand why we needed an HTAP solution. So I'm going to be talking quite a bit about our product and kind of our journey through our startup phase and how we got to where we are. So I'm going to talk about Catalyst from a product perspective. I'm going to characterize our data workload, which is quite large and varied, if you will. I'll walk through our kind of current target architecture and then walk through the process that we went through. Okay, what is Catalyst? So we're a customer success platform. What does that mean? It means that we succeed when our customers succeed with their customers. It's really meta, and it's actually kind of hard to say. But the fact of the matter is, especially in an economic downturn, you need to get the most out of your existing customer base, just because it's harder and harder to get new customers in. So Catalyst, our mission is to create a world where customer success is at the heart of every decision, such that you're reducing churn, you're making sure that the customers you already have are still there, they're still happy. It's all about customer. It's very customer-centric. So how do we do this? Well, data. We're fundamentally a data company. I mean, that's really the heart of our product. We hoover in a whole bunch of data from a very kind of disparate set of sources over there. Salesforce is one of our primary data sources. We get a lot of data from there. Mixpanel for basically event time series data, Postgres. We also integrate with a few data warehouses, that kind of stuff. So we get all of this data, we suck it into the Catalyst ecosystem, where we then do a whole bunch of stuff. So there's some analyzing. We actually hook up data from different data sources, which is a much harder problem than you'd think. And then we actually provide actionable insights to our customers based on that data that we have pulled in from their data integrations. And then on the other side, happy customers. All right, so this is just a screen cap. I don't actually think this is a real view of our system, but it's a notional view of our system. I believe this was produced by a designer, but I just kind of wanted to give everyone a flavor of the type of data and the type of data aggregations that we're dealing with. So you see all of this. None of this data is really generated from within Catalyst. This all comes from our external integrations. So a customer will sign up for Catalyst and they'll hook up their Salesforce instance, and we'll then pull in that data, put it into our system, do a whole bunch of analysis, a whole bunch of stuff on the data, and then produce things like these roll-ups. So for example, email engagement. We just released a pretty massive email product, so we now actually pull in our customers' email data, and then we provide aggregates and roll-ups based on that. So as you can imagine, it takes a lot of work and a lot of data to get to that 46% number. And so that's really kind of the magic of Catalyst, is we pull in this data, we do all of this like slicing and dicing, and then present it to you as our customer. All right, so what types of data are we dealing with? So again, transactional. We do have internal objects, so we do collect notes and tasks. We allow our customers to go into our platform and create notes and tasks, and then associate them to various external data objects. And those are typically Salesforce objects or Zendesk objects, that kind of thing. So we talk about the big three: accounts, contacts, and opportunities a lot. That's all Salesforce data. And so there's a lot of connecting the dots between these different data objects, which again is kind of quite the challenge. And then second, we have read-only objects. So we pull in data from Jira, from Zendesk, a few other integrations. We have data warehouse integrations. So if you have a Snowflake instance, given the appropriate schema, we can actually pull that data into the Catalyst system as well. And then finally, and this is where things get really interesting, is we do in fact have a lot of time series data. And I'm going to talk about time series a lot because this is one of the major selection criteria that we were worried about when we actually went into this exercise of selecting TiDB. When I say product usage, I really mean products like Mixpanel or Segment. I think Heap is another one. So basically, customers can instrument their website to detect the user patterns. So when you click on a button, it generates basically a mixed panel event, which is a time-stamped event. So this is by definition a time series. And we have a lot of time series data. And again, we have to combine this and couple it with the more transactional data. So it's a very different and interesting set of problems when you're dealing with transactional versus time series data. All right. So we have a lot of problems. And I'm going to walk you through kind of the Catalyst journey. So we're going to start off from the very start. All right, so we're a scrappy startup. Again, Series B, so we're still a pretty young company. So what do? Well, you go with Ruby, Rails, and Postgres. Tried and true solution. Pretty easy to do. Lots of engineers in the world know how to deal with this stuff. What's the next problem? Well, from the previous slide, we have a ton of different data sources, and it's really it's hard to make sense of all of that. So what do? You store it as JSON documents. Specifically, we're storing it in the legacy system, and I am speaking of the legacy system at this point. Specifically, we're storing it as a JSON-B column in a Postgres instance. And that's great. It's cool. It's a document store. However, the query performance is not great. It doesn't join very well specifically. So what do? Well, you do a whole bunch of pre-caching. So you basically do the joins ahead of time and then store the results in an elastic cache instance such that you can actually provide the data to the customer in sub-second time. Well, you can't really join on Elasticsearch, so that's a problem. So you have to basically pre-compute literally everything. So we're going to cache more data. We're going to cache the relationships between all of the different objects. Well, we need more. We could not have comprehended the different types of data relationships our customers would need. So store more data. You kind of see where I'm getting at. There's a bunch of stuff in Elasticsearch at this point. Elasticsearch is not cheap. What do now? Well, at this point, we re-architect. And so that's kind of where our journey towards TiDB starts. Okay, so we have just a ton of data now, and it's currently in basically a Postgres and Elasticsearch coupling. So in the new architecture, we're just going to go straight to a data lake. Just dump it right there. We'll deal with processing it later. We just need to get it into our ecosystem so that we can actually do the analysis we need. Data lakes are not optimized for real-time searches. You cannot provide a result in less than a second to a customer querying directly into a data lake. So we devised this data caching layer. And this is basically a subset of the data lake that's been processed and put into like a rational schema so that we can actually reason about the data format itself. And so that all goes into this data serving layer that's part of the architecture. Okay, so as I alluded to before, we have time series data and object data. So that's complicated. What do? So we need a row-based solution coupled with a columnar solution. That's transactional and analytical. What do now? So here is our architecture. This is how we have solved these problems. So again, this is not comprehensive, but this is a subset of the integrations that we provide our customers. And so all of this, we actually use Fivetran to ingest all of this data. Now, Fivetran is a great product. It doesn't support every integration yet. I'm hoping to convince them to support every integration ever, because integrations as a service is a brilliant idea. I don't want to sit there and write a piece of code that goes out to the Salesforce API, for example, because then I have to support that code. And I have to support that code when Salesforce changes their API. I have to write retry logic. I have to write load balancing. It's just a lot of work just for a very simple data integration. So that's why we went with Fivetran, because honestly, like we pay them and they handle all that stuff for us. Okay, so that's the data ingest layer. Okay, so it's kind of topical, Databricks. We had heard some good conversations about that. So we're using Databricks for our data lake layer. Now, technically, it's actually stored in S3 as Parquet files if you actually dig into how Databricks handles its lakehouse architecture. And then further, we're using Databricks for the Spark compute layer. Now, this is where we do all of the data enrichment, data analysis. We combine all the different objects. We do pre-computations for some, common queries for our customers, and that's all done again within the Databricks ecosystem using Spark. And here we come to TiDB. As I alluded to, we have a data serving layer. So basically, what happens? The raw data comes in through the ingest layer, winds up in the lake. We then use Spark to combine things, enrich data, make sure it all makes sense, make sure we have data quality checks. That's actually a good point. I'm glad I reminded myself. We do have a lot of data quality checks at this layer. When you're dealing with raw data specifically, you're going to come up with some weird stuff. So you do actually really have to work on that observability and the data quality checks. So that's a very important piece of this. So at the very end of the day, what you get is the enriched data that has been quality checked, and then it winds up in the data serving layer, which we are using TiDB for. And then finally, I actually left a step here. There's still a Rails backend that's actually behind the Vue web app, but I figured I could leave that out and everybody would understand it okay. Okay, for the remainder of this talk, we're going to be talking about the data serving layer, because this is really where the heart of it comes into. This is where TiDB comes into it. Everything below the data serving layer can be non-real-time. However, at the data serving layer, this is where we need to get the sub-second latency so that our customers get their results quickly, and they trust our system. Okay, so let's talk about a few requirements that this architecture needed. So again, speed, we needed to compete with Elasticsearch in terms of query and user interface performance, so which means sub-second access and also low update latency. Now, that last one's a little tricky because, as you may have noticed, there's a lot of processing that's going on before you even get to the data access layer. And that's honestly still a problem. We're dealing with that now. We're still trying to reduce the latency from the Fivetran ingest into the data access layer. It's a journey. We'll get there, hopefully. And then here's the rub. If we had a really good sense for what our query patterns were, we wouldn't need anything nearly as complicated. The problem is that within the Catalyst platform, our customers get to define their own queries. They get to define their own data transformations, and they get to define their own relationships between objects. Now, that last one is scary, and that scared the crap out of me, because literally, there are custom objects in Salesforce, Zendesk, and a few other platforms that some of our customers actually swap out for the high-level account object. So I'll give you an example. Say I'm Joe Schmo customer, and I actually have this object called custom account, and that's what I consider to be an account. So what that means is everything we know about the way that the Salesforce data works and is structured is just out the door, because it's a custom object with a whole bunch of custom fields. And that is a very, very scary and complicated problem. Utilities, obviously, high availability is huge. If our platform is down, then our customers suffer. I mean, it's a bad deal. We actually have a very responsive customer set. Whenever Catalyst is down, it's honestly within tens of seconds that we get hit up by a customer. It's super annoying. Scalability, obviously. We have a lot of data, and it's just going to get more and more. We're just going to always get there. The system itself is designed to be eventually consistent. Again, that's a lot of processing going up that flow. So it's really hard to get strong consistency through the entire system. So we're okay with eventual consistency, and our customers are as well. A lot of this data gets synced on a relatively large time span, honestly on the number of hours for some integrations. So our customers don't really expect to make a change and have it show up immediately within the Catalyst system. So we do have a lot of wiggle room there, which is really nice. And so we've tried to use that fact to our benefit. And then a few nice to haves. Single data store. I mentioned, we have transactional data and analytical data. It'd be nice if we can keep them in the same place. Don't really need to. I mean, there is a world where we have basically a time series database and a transactional database, and then we join basically in memory. It's not a great architecture, but it does work. It's problematic, very difficult to manage, very difficult to reason about, but you can do that. But, you know, it'd be nice to have them all in the same place. And then I'm slightly allergic to non-managed solutions these days. I was talking beforehand. I mean, the fact of the matter is we have a very small DevOps organization, and as an architect, I'm very hesitant to add more load to them. They're already like fully baked out. So, you know, going with the fully managed solution really pulls a lot of the work off of their plate. And then finally, cloud agnostic. Catalyst, as we are now, we're in a slightly odd place. We're straddling two clouds. We have some workload in GCP, some workload in AWS. So, you know, just in order to give us more flexibility there, it would be nice to have a cloud agnostic system, which typically flies in the face of fully managed, but luckily, that's not always the case. Okay, so how did we make this decision to go with TiDB? We talked a little bit in the keynote about this. We touched on it. We basically devised this hackhouse, a hackathon event. So we got 5 engineers and 1 Airbnb for 9 straight days. And yes, we did work over the weekend. Yes, we worked a lot. And yes, we had a lot of fun. Just a quick note, we called it the Denver Death Squad. This did occur in Denver. It was about a mile from my house, which was super convenient for me. But the name itself, there's actually 2 competing origin stories for this. A couple of days before we were due to leave, our CEO slacked a meme of the movie Armageddon, saying that, hey, I feel like you guys are going off to save the world. And then we got thinking about it, and we realized that not all of them made it back in that movie. So that was a little disconcerting. So anyway, we named ourselves the Denver Death Squad. The competing story is that DEATH is actually an acronym for, damned, experienced, and totally hot. So pick whichever one you like. So yeah, so we got in this Airbnb and we started prototyping. We started coding. It was a lot of long days, a lot of coding. We went in with basically 3 options in mind. We wanted a standard OLTP database. We wanted a cloud-native OLTP database, and we wanted to evaluate this new HTAP thing, because it seems cool. And I'm, by nature, a very skeptical person. I don't necessarily like bleeding-edge tech. I like to see it behave in the wild. I like to see how it behaves in production. I like to read papers about it. I'm very nervous about brand new things. So, you know, that's one of the main reasons why we actually set out on this exercise at all, because I'm just skeptical. And I will point out too, HTAP is the only of these 3 that allowed us to combine the time series with the transactional piece. So for the top 2, we were actually evaluating pairs of tech. I can't remember if I have it written down. No, I do not. But the pairs themselves, so we were looking at Aurora/RDS plus AWS time series, and we were looking at Yugabyte plus AWS time series, and then we were looking at TiDB for the HTAP portion. And then we had one goal coming out of this, and that's to decide on the tech stack for the serving layer. We were not allowed to leave that dark, dingy Airbnb until we had a solution in mind. One thing I do want to point out too, it was a very diverse group of engineers. We had a full stack engineer, we had a data engineer, we had a back-end engineer, and we had an SRE. So it was really nice that we kind of covered all the different bases of the entire system. Having the SRE was nice because he could just like whip out some Terraform and spin up some infrastructure for us, while the back-end, full stack, and data engineers actually worked on prototyping out the software. So that's a key thing. We really rounded out the corners of all of the different options by this very diverse group of engineers. Okay, so as I mentioned, this is what we did. Again, if we're using like something like AWS RDS or Aurora or something like that, it doesn't really work with the time series component of our system. So we had to evaluate kind of that pair. Whereas HTAP, TiDB specifically, kind of allowed us to combine these 2 technologies into one stack. And again, oh, I did have this slide. Good for me. 3 solutions, cloud-native database that was Aurora, strictly speaking. or no, cloud native was Yugabyte, Aurora, and then time series, and then TiDB. Okay, so as I mentioned, we do have a lot of data. So that's kind of nice in that we could basically take some subset of our production data, copy it into this test environment, and then run based off of that. So we started off, we didn't do everything with all of our integrations. We basically started off with Salesforce and Jira, and then realized that we didn't have time for Jira, so we just did Salesforce. It is what it is. We also, by virtue of this hackathon, we also implemented a simple random data generator just to kind of beef it up, just so we can actually do some more performance testing. And the data sets themselves were on the order of tens of millions of rows. Now, that's not very much in the grand scheme of things. However, that is pretty indicative of an individual customer in Catalyst. So, and given our sharding structure, this was okay. We're basically sharding everything based off of customers. So whatever one customer's performance profile is going to be pretty indicative. So that's why we did that. Then finally, we took a representative subset of likely customer queries. Our product folks were very generous enough to give us an entire set of queries that our typical customer would be interested in. And then we ran those queries continuously under heavy load. And again, we did this for the 3 solutions provided. So here's just a few results. I'm not going to get too much into the weeds here. I do have more data sitting around somewhere. It's considered somewhat sensitive around Catalyst, so I'm not going to get too much into it. But in general, what we were seeing for OLTP, and again, this is specifically Postgres on Aurora, we were seeing about a 30-second query time average. And again, this was for these indicative queries that our customers were interested in. The aggregation queries, like the time series queries, they were taking about 2 minutes on average, which is pretty slow. Or actually, I apologize. The time series aggregation we actually didn't get to. The aggregation was basically like computations based on these very complicated joins. And so once you start tacking on joins, and we didn't do any optimization, I should clear that up now. We probably could have gotten this way down if we had done the proper indexing, but we didn't have time, so we didn't do it. Okay, and again, we didn't optimize this, but this was just the raw results from TiDB. Like for the exact same queries under heavy load, we were seeing about 3-second queries on average. Now again, that's not that sub-second query that our customers need, but again, this was a very untuned and honestly very small TiDB instance. And then again, the aggregation queries went from 2 minutes to 2 seconds, and then we actually did test the time series aggregation on TiDB, and that was right around the 7-second mark. So we figured this was a pretty good performance indicator. And that's actually it in terms of selecting the tech stack. I did want to give a few random observations throughout the entire thing. You know, as an architect, it can be sometimes difficult to go to bat for your architecture. Get data. It gives you a lot of leeway, a lot of like power to actually argue that yes, this is the correct architecture for our system. This is the correct architecture for our customers. So start with data. Similarly, always prototype. Like this entire thing was one gigantic 9-day prototyping exercise. I feel way better about, honestly, any architecture that I devise or even anyone else devises if there's a prototype that I can actually see and poke and code and like try and break. Always prototype. It just gives you so much more confidence. And also it can be a really good, you know, starting point for the actual production code as well, depending on how good you are at coding a prototype. As far as the hackathon, hackhouse kind of structure, it's really, if you're ever going to do this, and I would suggest it, it's kind of it's a thing, like it's difficult to argue for, and you know, if you can convince your management to do it, it's a lot of fun and well worth it. But if you're going to do it, have a clear goal. Like I said, we had one goal going in, and that was to decide the tech stack for this one piece of our architecture. And we could not leave until we did that. So have one goal going in. And also plan the work well in advance. I was probably in Jira for a week straight, just like putting the stories out, laying out what exactly we were going to do through this 9-day hackathon. And that really went a long way, honestly, just like keeping us on track. Like we had a daily stand-up basically where we'd go through the tickets that we knocked off. And furthermore, it actually gave me something that I could present to my management to say, hey, look at all these stories we knocked out in these 9 days. It's very clear. It creates a sense of transparency. It lets you know what you're doing, where you're going, and it also gives you this really nice transparency. And then finally, be cautious of new technologies. As I said, I'm a skeptic. Don't be scared, though. Like, had I been too scared to try HTAP, then I wouldn't be here today. So just be careful. All right. So that was pretty quick. Nice. So what did we talk about? So our system, scrappy startup, Ruby, Rails, Postgres, we were starting to hit like significant limits. We actually started going through some really crazy hoops to scale horizontally that worked to a degree. However, they were not going to work forever, so we actually had to re-architect. The data serving layer, again, is a critical piece because that's what actually drives the data that goes to our customers. And we definitely needed to get that part right. This was, at least in my opinion, this was one of the most critical pieces of that architecture. We just had to get that right. If we didn't get that right, then the entire system was not really going to work for our customers. And then, again, at the end of the day, HTAP was, by and large, the clear winner. And that's it. You may ask questions.
I'll go. So this might be a hard one to answer on the spot, so don't worry if you can't. But I'm curious if you have an example of like some type of insight or some type of query where you did combine the transactional data and the time series data. I've always been curious about those use cases. I'm sure there's millions, but do you have one off the top of your head?
Yeah, that's a great question. Customer engagement. That's a good one. So I mentioned our product usage data, so the mix panel. That's basically a telemetry stream of users clicking buttons and web apps and typing stuff. All that data has to be aggregated and then associated with an actual person in Salesforce. So that it's actually a pretty clear example, I think. Does that answer your question? Yeah.
Just want to understand your workload pattern. Is it mostly read only? I think at one of the slides you mentioned, but the performance improvement is really amazing. I just wonder if your workload is mostly read only, and do you have any write throughput or performance comparison? Yeah.
Yeah, it's a good question. I was actually trying to not talk about that, so thank you. I'm just kidding. I'm happy to talk about that. It's a very, very read-heavy workload, very, very read-heavy. However, within Catalyst, you can actually update a field in Catalyst, and it will it'll push that data to Salesforce, which creates this very bizarre feedback loop. And it's actually really kind of difficult to get right. And to be quite frank, we're still struggling with the best way of actually executing on that. There's a few options on the table. We're kind of toying around with the idea of doing an optimistic write to the data serving layer while we write out to our external data service, while we write out to which basically will, in theory, become eventually consistent once the integration comes through Fivetran and then back up into the data lake and then back up into the serving layer. So that was a lot of words to say that it is probably 95% reads, but the write cases are very complicated to deal with. And we're still kind of toying around with some solutions there.
So you mentioned sharding at some point during this talk. I think it was very briefly. I'm curious, are you running a separate TiDB cluster for each of your customers? And if so, have you considered multi-tenancy?
We are not running a cluster per customer. I'm kind of interested in doing that because we have some very large customers. I don't see a world in which we're fully single tenant. Multi-tenancy is just, you have to do that to reduce costs. That's just a fact of the matter. But you know, if we were to onboard like a gigantic customer, I'm kind of personally interested in what would that look like if we were to like basically programmatically spin up a brand new TiDB cluster for them. Now that's kind of future looking. For right now, we're sharding. So basically, each customer has its own logical database within a single TiDB cluster, and that's that's kind of the easiest way of doing it. We're still evaluating the performance, seeing do we need to actually scale this out further, so on and so forth.
Makes sense. Sorry, one quick follow-up. If you are doing multi-tenancy, like you were also considering Aurora, you weren't worried about Aurora running out of storage.
I was very worried about that.
I see. So that was another reason you chose
Yeah.
to go with this. Thanks.
Yep.
I'll go again. Still trying to determine if this question makes sense in my own head, so I'll give it a shot anyways. It seemed like the data that you were serving through the server, at least what you spoke about in the serving layer, was all data that was coming through Fivetran ultimately, and data that was coming from other sources. But I imagine there's some set of data that has to do with people interacting with Catalyst itself, right? So there's some sort of OLTP going on there, maybe. Are you doing any OLAP-y kind of work or aggregations on that data, sort of live in the data serving layer?
Yeah, we definitely are. Thanks for asking that, actually. Yeah, like I said, notes and tasks are objects that originate from within Catalyst that we also need to do processing on. Our current solution is we're using a CDC mechanism. So there's currently no plan to deprecate our existing Postgres database. We just need to get all the big data out of it. So we'll probably, quite honestly, always have a Postgres instance, which means that there's a fair amount of transactional objects that will get dealt with there. And then our current architecture has a CDCing using Debezium over into the data lake itself, where it then just flows through the existing data processing pipelines, if that makes sense.
I have a question.
Yeah.
So what do you do today with disaster recovery and backups?
Ooh, now there's a question. So today, let me break this into two parts. So there's the pre-serving layer, pre-data serving layer world where it's really just Postgres and Ruby on Rails. And for that, we're using a company called Ivan. It's basically a fully managed, it's basically an Aurora competitor, if you will. So they handle all of our backups and data recovery for us. In the not too distant future, and by not too distant future, I mean like honestly now, like we actually do have TiDB running in production at the moment. It's not fully up to scale yet. There's still some data that has not made it through this development process to get there. But suffice it to say, we are actually running with some data in production within TiDB. And as far as disaster recovery there goes, again, we're kind of we're using TiDB Cloud. Again, I'm kind of allergic to non-managed solutions. It just freaks me out. So, we're honestly relying pretty heavily on that aspect of the managed solution, both historically and in the new architecture.
Thank you. That's your cue.
I'll drop the mic now.